For section 3.3, I used the same table as the example that we did from 3.2 once again. Only difference now is that we're talking about mutually exclusive events rather than independent and dependent events. For two events to be mutually exclusive, that means that they cannot occur at the same time. Whereas remember, for the independence factor, in order for it to be independent, you had to have the original probability be the same as the conditional probability. So in other words, that one didn't change, so it was not dependent on anything else. Whereas in this section, we're dealing with mutually exclusive. Mutually exclusive means that the two events cannot happen at the same time. It's a little bit of difference there. So here in this case, for part A, we wanted to determine if the events of having a purebred dog and a mixed breed dog are mutually exclusive. So that's the first part. So in other words, is it possible for a dog to be both a purebred and a mixed breed dog? So the answer for that is no, it's not possible for it to be both. So since it's not possible for it to be both a purebred and a mixed breed dog, that means that it is mutually exclusive. So I'll abbreviate it here. It is mutually exclusive because they cannot happen at the same time. They can't be both purebred and mixed breed dog at the same time for that same dog. So that means that they are mutually exclusive. You know, sometimes it's easy to get those mixed up there. And then to figure out the probability there of having a purebred or a mixed breed dog, since we know that it's mutually exclusive, to find that probability, so remember that P in front means probability of purebred or mixed breed. That's the same thing as saying probability of it being purebred plus the probability of it being mixed breed. So if they're mutually exclusive, remember just like it has in your book, that means you can just add those two probabilities separately together to get the total probability there. So in this case, of it being purebred, would be 57 out of the 107, plus mixed breed is 50 out of the 107. So there we get 107 out of 107, which equals 1, which should make sense that any of the dogs that are selected here are going to be either purebred or a mixed breed dog. There's nothing else to choose from, so that probability is 100% or 1 as a decimal. For part B, once again, we're trying to determine if the events are mutually exclusive or not. In this case, we have to determine if the events of having a purebred dog and spending less than $100 are mutually exclusive. So for this one, we have to determine if having a purebred dog and spending less than $100, if both of those events could happen at the same time. Which of course they can, because it's possible for your dog to be purebred and spend less than $100. In fact, that would be represented by this 25 right here, would be the probability of having a purebred dog that you spent less than $100 on. So it's definitely possible for it to be both. So that means that this one is not mutually exclusive in terms of these two events. So remember, if the events can happen at the same time, that means it's not mutually exclusive. If they cannot happen at the same time, then they are mutually exclusive. So it might seem kind of contradictory of what you might think originally, but that's our definition there. So if they're not mutually exclusive, then we have to use that other form of the probability of one event or another to find the probability of the dog being purebred or spending less than $100. So for this one, to find the probability purebred or we'll use the less than sign, less than $100. To find this, we'll have to do probability of it being purebred plus, once again, the probability of it being less than $100. But because they have something in common, because there are some values that are purebred and less than $100, we have to subtract off that value. So we have to subtract off the probability that it's pure, and, so I'm going to use this little symbol here for and, less than $100. So we still add together the two separate probabilities, but we also have to subtract off the intersection, what they have in common, so that way we're not counting it twice. So here in this case, for purebred, once again, we have 57 out of the total of 107 for the number of purebred dogs out of the total, plus, and then spending $100 or less. So if I look back up on our table here, for spending $100 or less, we had 55 here. We used this 57 before to get that purebred. The 55 is the total for the amount spent less than $100. So we'd have 55 out of the total, once again the overall total, minus the number that had purebred dog and spent less than $100. So that was the value that I put the arrow by originally up here, that 25 out of the 107. And one way to double check this too, if you were going to add together that 57 and the 55, we'd get more than 107. And remember, your probabilities always need to be between 0 and 1. If you're thinking of them in terms of decimals, or between 0% and 100% if you're thinking of them in terms of percentages. If you get a value above 100% or below 0, then you did something wrong in your calculations. So here, if we add together 57, 55, and then subtract off that 25 there, you should get 87 out of that total there of the 107. And once again, if you want to, you can approximate that here as a decimal. Make sure to go out at least 3 decimal places if you do so. So here we'd get approximately 0.813 for our probability in that case.